Hi, everyone. Welcome to the Lamont Open House. My name is Nathan Lenssen, and I'm going to be walking you through an activity called Fold and Forecast today. This activity will take you about 15 to 30 minutes, and we're going to do some fun things. We're going to get to build paper airplanes. We're going to get to learn about forecasts of rain and of climate phenomena, and we're going to get to move around the room a little and cause a little bit of trouble. So something that motivates a lot of what I think about at Lamont as a grad student researching forecasting is how to convey information when we're not certain an outcome is going to happen. An example of this we deal with every day is rain forecasts. So this is the forecast for the last week in New York City. And if you remember, we had a lot of rain early in the week. But when I was making this video early in the week, we weren't sure if it was going to rain or not on Friday. So on Monday, there was a forecast of a 50% chance of rain on Friday. And we've all seen forecasts like this before, and we don't really know often what that means. Does that mean it's going to half rain? Does that mean it's going to rain, but like only half as much? Does that mean it's going to not rain, but maybe if we're really unlucky, it will? And so today we're going to use actually paper airplanes to look into how forecasters issue a forecast like this 50%. So we're now going to build some paper airplanes and make some throws to try to understand what this 50% actually means. All right, so the first thing we're going to need to do this activity is 3 to as many as you can make paper airplanes, but make sure you make at least 3 of them. And I'm going to walk you through right now a pretty simple way to make a paper airplane. So the first thing you're going to do is take a piece of paper and fold it in half hot dog style. And make sure you give it a nice good crease. And then open it up with the crease down and fold the top corners down so they meet the middle crease like this into a point. And then you'll take the other side and do the same. And this paper airplane is pretty fast, but not fast enough. So we're going to take it again and fold it into the middle one more time, making the point even sharper. And again, take the point in and fold it across. And now when your paper airplane looks something like this, we're going to fold it in half, making sure everything's nice and pressed down again. And then fold down the wings. So taking the wing across, I'm going to just kind of pick a point somewhere around here and try to fold it straight across. And flip it over. And do the same, trying to make the wings line up. And then once you're done, you can open it up. Get those wings nice and up. And you have a paper airplane ready to fly. If you want, as a finishing touch, you can add cool little wing flaps on the edge or wing tails. And it'll be speedy and ready to do some weather and climate prediction. So now that you made one of these, either find your friend or mom or dad or brother and sister and have them make one, or make a few more until you have at least 3 of them. Great, so now we should have all of our paper airplanes folded. I made up 4. And I've marked a place on my floor right here with a dish towel. So I know that I'm going to be throwing from the same place each time. And I've also created this sign, which I put on the floor. And the point of this is that any paper airplane that gets past this line will mean that we're forecasting rain. And any paper airplane that doesn't get past this line means we're going to forecast not rain. And so you can make a sign like this just by kind of writing on a piece of paper, or you can just put another thing like a dish towel or a cup or whatever you can find down on the ground. But we just need to mark one line on the ground, which is going to divide between our forecast of rain and our forecast of no rain. So now hopefully our paper airplanes are all pretty much about the same. And this next step is really important, that we're going to be taking all of these paper airplanes and we're going to try to throw them exactly the same. And so this is going to approximate the fact that any forecast is starting with the same starting conditions or initial conditions. But there's still uncertainty, there's still chaos that causes the paper airplane or the forecast to end up in different results. So right now, we're going to take all of our paper airplanes, pause the video, and throw all of them as exactly the same as we possible towards the line dividing between rain and no rain. So here now you can get a better look at my setup and also the results of my first forecast I'm making. So that towel on the floor over there, the blue one, was my start line where I threw 4 paper airplanes with all the same motion. And here again is my sign marking rain versus no rain. So all paper airplanes that got above it are forecasting rain, and all forecast planes that did not get above it down here are forecasting no rain. And so in my forecast, I threw 4 paper airplanes and 3 of them made it across the rain category. So in this case, my forecast would be for a 75% chance of rain for this upcoming day. Maybe your paper airplanes look different. So now look at your paper airplanes and try to calculate yourself what your forecast will be. Count how many paper airplanes made it across into rain and divide by the total number of paper airplanes you've thrown. So we saw in that activity where making multiple forecasts, in my case 4 of them, for whether it's going to rain or not, allows us to issue a statement with some probability. Since 3 out of the 4 of my paper airplanes crossed the line for rain, the forecast that I would issue would be 75% chance of rain. This is a really important problem in weather that comes up all the time, and as we saw in New York City every week. A problem we think a lot about in my lab at the IRI is whether or not this upcoming winter is going to be an El Nino winter or a La Nina winter. El Nino and La Nina are conditions in the Pacific Ocean that correspond to anomalously warm or cool temperatures. And these temperatures in the Pacific have impacts on weather and climate all around the world. So they're really important for understanding and trying to predict how these temperatures are going to evolve. The current forecast for El Nino and La Nina conditions looks something like this. And there's a lot going on in this chat plot, but let's just focus on kind of one section. For the upcoming December, January, February season right here, the current forecast is around a 70% chance of La Nina and around a 30% chance of neutral, with just about 0 chance of El Nino. So summarizing this, for this winter, we're saying that there's about a 70% chance of La Nina. We're going to again replicate this pattern or this forecast using our paper airplanes, except instead of 2 categories, rain and no rain, we now have 3 categories. El Nino, which corresponds to warmer temperatures than normal in the Pacific, neutral, which corresponds to normal temperatures in the Pacific, and La Nina, which corresponds to cooler temperatures than normal in the Pacific. And this is a pretty neat example as well, because these forecasts are actually calculated from paths of paper airplanes, basically, or paths of models. So when we're starting at a single point, like here, standing on that start line, each model, which is a different color here, follows its own path. And you can think about these as all the different paper airplane throws. And to go back from this plot to this one, we're just counting how many paper airplanes fall into each of the categories. So now that we've seen a little bit of the actual forecasts, let's go back to our paper airplanes and make some more forecasts ourselves. Like the precipitation forecasting activity, we're going to have a divider. But in this case, since we have 3 categories, El Nino, neutral, and La Nina, we're going to have 2 different dividers. So again, I've printed out these 2 dividers that will be the boundary between El Nino and neutral on the warm end, and La Nina and neutral on the cool end. So I will have the El Nino boundary further away from me and the La Nina closer to me. And again, you could just use 2 markers of any type, whether it's a piece of paper or a towel or something small. So again, I'm going to place these out on the floor in front of my starting line. And like before, trying to throw my paper airplanes in exactly the same way, I'm going to take each of my airplanes and throw them one by one. So again, here's our forecasting setup. Reminder that my start line is that blue towel over there. So this first category right in here is the La Nina conditions. This right here is neutral, and this is the warm El Nino conditions past here. And so you can see from my throws that I had 1 airplane land in the neutral zone, meaning about normal conditions in the Pacific, and I had 3 paper airplanes of my 4 land in the La Nina, or cool. And so this forecast would then be a 75% chance of La Nina conditions and a 25% chance of neutral conditions and a 0% chance of El Nino. And so you can imagine also if maybe I had thrown the paper planes, all 4 of them, much harder, they could have all landed up in the El Nino, or a mix between El Nino and neutral. And so if they all had landed up in El Nino, our forecast would be 100% chance of El Nino. Well, thanks everyone for sitting down with me today and joining me in some fun activity. I hope you learned a new way to fold a paper airplane, or at least perfected this way, and now have a better idea of what that precipitation forecast in your weather looks like, and a little bit more about how climate forecasters think about upcoming El Ninos or like the upcoming La Nina. So thanks again for joining us, and be sure to check out all the other activities around Open House and stop by next year when we're back in business.